Welcome to the DIY Honda Garage channel. The DTC P0555 indicates an issue related to the brake booster pressure sensor A circuit, specifically signaling a high voltage condition. This sensor plays a crucial role in the braking system by measuring the pressure in the brake booster, which aids in the application of the brakes. Its accurate readings are essential for the powertrain control module, PCM, to manage engine performance during braking scenarios. The brake booster pressure sensor is typically located near the brake booster in the engine compartment, ensuring it can accurately measure pressure. When the output voltage from this sensor exceeds the specified threshold of 4.71 volts, the PCM recognizes an anomaly and triggers this diagnostic trouble code, which is stored in the vehicle system for further troubleshooting. Understanding the relationship between the sensor, circuit integrity, and the PCM is vital in resolving the DTC effectively. The P0555 trouble code represents a scenario where the voltage output from the brake booster pressure sensor is excessively high. The main component at play here is the brake booster pressure sensor, which is designed to monitor the vacuum within the brake booster. This sensor directly contributes to the effectiveness of the brake system, enabling the vehicle to achieve optimized braking performance based on real-time measurements. Positioned close to the brake booster, the sensor's immediate access to braking pressure is crucial for timely and accurate feedback to the PCM. In normal operation, the sensor transmits voltage signals to the PCM, which uses this data to adapt engine operations accordingly. However, exceeding the specified voltage indicates a potential fault within the sensor itself, the wiring, or even the PCM, thereby necessitating further diagnostics to pinpoint the exact issue. Several factors can lead to the setting of the P0555 trouble code. One of the most common causes is a malfunctioning brake booster pressure sensor, which could be due to internal faults or wear over time. This can result in incorrect voltage readings being relayed to the PCM. Another potential cause could be an open circuit within the wiring harness, disrupting the communication between the sensor and the PCM. Similarly, a short circuit can arise, causing an unintended increase in voltage levels. Lastly, while less common, issues within the PCM itself can cause it to misinterpret the signals received from the sensor, leading to further complications. It is critical to thoroughly inspect each of these components to determine the precise root of the problem and ensure a proper resolution. When the P0555 trouble code is triggered, several symptoms may manifest that can alert the driver to potential issues with the braking system. The most immediate indication is often the activation of the warning light on the dashboard, which serves as a cue for the driver to seek maintenance. Additionally, braking performance may become compromised, leading to a softer brake pedal feel or delayed stopping distances, which can significantly affect vehicle safety. In some cases, drivers might also notice decreased engine responsiveness, particularly during braking scenarios, as the PCM could be struggling to manage the engine's performance due to erroneous signals from the brake booster pressure sensor. Because braking is essential for safe vehicle operation, it's crucial to address these symptoms promptly. The first step in troubleshooting the DTC P0555 involves turning the vehicle to the on mode and utilizing the HDS, or Honda Diagnostic System, to monitor the brake booster pressure sensor's A voltage. Specifically, you need to observe if the HDS displays a brake booster pressure sensor A voltage value of more than 4.71 volts. This measurement is crucial because it directly indicates whether the failure condition has been duplicated as per the DTC description. If the voltage exceeds this threshold, it confirms the presence of an anomaly within the circuit or the sensor itself. On the other hand, if it displays a normal value, further diagnostic procedures will need to be conducted to pinpoint the issue more accurately. This confirmation stage is vital in narrowing down the possibilities and determining the next steps needed. Following the initial confirmation, the next step is to focus on the VAC1 circuit, which carries the voltage signal from the brake booster pressure sensor to the PCM. Before proceeding, ensure that both the brake booster pressure sensor 3P connector and the PCM connector A 50P are disconnected to avoid any electrical shorts during inspection. The procedure requires conducting an open wire inspection. Ideally, the resistance should be less than 1 ohm. This specification indicates that the circuit is intact and capable of transmitting signals effectively without any interruptions or excessive resistance. If the readings indicate a higher resistance or abnormalities, this would suggest a fault in the wiring that must be addressed before further tests can proceed. Identifying and rectifying any wiring issues in the VAC1 circuit is essential for restoring proper communication between the sensor and the PCM. After inspecting the VAC1 circuit, the next phase in troubleshooting the DTC P0555 is to turn attention to the SG6 circuit, which serves as the ground for the brake booster pressure sensor. Again, it is crucial to disconnect the brake booster pressure sensor 3P connector and the PCM connector E 80P before conducting the inspection. You will perform an open wire inspection similar to the previous step, focusing on ensuring that the resistance remains less than 1 ohm. This ensures that the ground path is secure and that there are no interruptions that could lead to erroneous voltage readings at the PCM. If testing reveals higher resistance, further investigations into the integrity of the SG6 ground circuit should be conducted, including thorough checks of the wiring and connections. Effective grounding is key to the accurate performance of the brake booster pressure sensor, thus solidifying its functionality within the vehicle's braking system. In this troubleshooting phase, the focus shifts toward the brake booster pressure sensor itself. Since there is no direct method to verify the sensor's operational integrity, utilize a known good brake booster pressure sensor to replace the existing one temporarily. This step is critical, as it allows for a direct comparison, which can help in determining whether the original sensor was the source of the problem. Once the new sensor is installed, monitor the vehicle to see if the failure condition reproduces or if the P0555 code recedes. If the symptoms persist, it may indicate that other components related to the sensor or the circuit itself are faulty. However, if the replacement sensor resolves the issue, it confirms that the original brake booster pressure sensor was indeed defective and warrants replacement to restore the vehicle's braking system functionality. If all other components and wiring have been investigated and deemed in normal working condition, the final step is to examine the powertrain control module, or PCM. Here, the goal is to ascertain whether the PCM itself is the root cause of the trouble code P0555. This involves checking to see if the previously conducted inspections indicated that all conditions were normal, particularly the voltage readings from the brake booster pressure sensor and the operational conditions of the wiring. If the testing confirms normal operations for the other components, yet the DTC persists, it is likely that the PCM has malfunctioned, leading to erroneous readings from the brake booster pressure sensor circuit. At this juncture, it may be necessary to either repair or replace the PCM to eliminate this issue and restore proper vehicle functionality. Upon resolving the issue indicated by the DTC P0555, it is essential to perform a final repair verification. Clear the diagnostic trouble code using the HDS and then conduct a road test to ensure all systems are functioning as intended. Pay close attention to the brake system behavior, as proper functioning hinges on accurate readings from the brake booster pressure sensor. Monitoring the HDS during the test will confirm whether the previous high voltage issue has been resolved and that the system operates seamlessly without any warnings. If any symptoms return or new issues arise, further investigation may be required to ensure that all aspects of the braking system and the PCM are functioning correctly. Successfully confirming that the repair has remedied the high voltage fault will warrant the conclusion of this repair process. To avoid encountering the DTC P0555 in the future, implementing preventive maintenance is crucial. Regular inspections of the wiring associated with the brake booster pressure sensor can help identify wear, corrosion, or any disruptions in the circuit that could lead to faults. Additionally, consistently monitoring the function of the brake booster pressure sensor, particularly during routine vehicle checkups, can provide early warnings of any potential failures. As with any critical system, maintaining the entire braking system will not only enhance performance, but also improve overall safety. This encapsulates checking fluid levels, ensuring brake lines are in good condition, and confirming that components function correctly, especially during high-stress conditions. By being proactive in maintenance, the likelihood of encountering similar trouble codes can be reduced significantly, thus ensuring consistent vehicle reliability. In summary, troubleshooting DTC P0555 is crucial for ensuring the safe operation of the Honda Civic 2022 Plus. Understanding the underlying causes of the high voltage condition in the brake booster pressure sensor circuit is essential for efficient diagnosis and successful repair. Monitoring critical components like the brake booster pressure sensor and the PCM facilitates quick responses to potential failures before they compromise vehicle safety. Addressing issues with diligence and performing regular vehicle maintenance helps in sustaining optimal performance. By following the outlined troubleshooting steps, technicians can effectively diagnose and resolve the DTC, ensuring the brake system functions correctly and the vehicle remains roadworthy. An emphasis on preventive measures will further mitigate the risk of similar problems in the future, promoting safer driving experiences for all Honda Civic owners. Please like and subscribe to the channel. See you next time.